All right, let's dive in. Today, we're going to pull back the curtain on Google Bigtable. You know, the powerhouse database that Google built to handle just absolutely insane amounts of data.
So let me ask you something. Your data? It's growing like crazy, right? But is your database actually ready for that? Or is it gonna, just fall over at some point? This is the exact problem Bigtable was built from the ground up to solve.
We've been hearing the term big data for years, but honestly, the scale of what we're dealing with today it's just mind-boggling. And the truth is, most traditional databases, they were never ever designed for this kind of challenge.
I mean, we're not just talking terabytes anymore, we're talking petabytes. That's 1,000 terabytes. And when you get to that kind of scale, which is pretty common now in things like IoT, finance, you name it, you can't just throw more hardware at your old database. You need a totally different way of thinking, a completely new architecture.
And that, my friends, is exactly where Google Bigtable enters the picture. Now, on paper, it's a NoSQL wide column store database. And I know that sounds kind of complicated, but don't worry about the jargon. The core idea behind it is actually super simple, and it's incredibly powerful. So let's break it down.
Okay, the real magic of Bigtable starts with this one concept, a sparsely populated table. So picture a spreadsheet. But not just any spreadsheet. Imagine one that has billions of rows and thousands of columns. Now here's the kicker, and this is the most important part. If a cell in that spreadsheet is empty, it takes up literally zero space. It just doesn't exist. This incredible efficiency is what lets it scale to just absurd levels.
And this table right here, it's a perfect illustration of what I'm talking about. Take a look at user number 123, that's Alice. We've got her name, email, country, and some usage stats, all good. Now, look at user 456, Bob. We only have his name and his last login time. See all those empty spots for email, country, and pages viewed? In a normal database, that would be wasted space. But in Bigtable, those blank spots take up no storage. None. Zip. You only pay in terms of storage for the data you actually have.
So, the big question is, why would you choose Bigtable over, say, rolling up your sleeves and managing your own open-source version like HBase? Well, it really boils down to this. You get way more power with way less of the management headache.
Let's talk scalability, because this is a huge one. With Bigtable, as you add more machines, your performance just goes up in a nice straight line. There are no hidden surprises, no bottlenecks. But with a lot of self-managed systems, you eventually hit this performance ceiling, this wall. And breaking through that wall means a painful, complex re-architecture. Bigtable is designed from day one to just never hit that wall.
And then you've got the day-to-day stuff, the actual administration. Bigtable handles all the really tricky parts for you. Things like upgrades, restarts, making sure your data is replicated and safe. It's all automatic. And what that really means is your engineers can spend their time building cool features, not babysitting a database cluster.
And the operational wins just keep on coming. You can resize your cluster to handle a sudden traffic spike with absolutely zero downtime. Bigtable is constantly balancing the load for you. And it can even auto-scale, adding or removing nodes all by itself based on the CPU load. I mean, the flexibility you get is just incredible.
Okay, so that all sounds great, but how does it actually do all this stuff? Well, the answer is in its absolutely brilliant architecture. So let's peek under the hood for a minute and find the secret sauce that makes Bigtable so incredibly scalable and resilient.
So let's follow a single request from your app. It sends a read or a write. That hits a front-end server, which is smart enough to route it to the right node in your cluster. Now that node figures out where your data lives. But, and listen closely because this is the most important part, the data is not on the node itself. The node just holds a pointer to where the data is stored, which is on Colossus, Google's massive, super durable distributed file system.
This quote right here just nails it. Data is never stored in Bigtable nodes themselves. You have to get this concept to understand Bigtable. Just think of it this way. The nodes are your compute layer. They do the thinking. And Colossus is your storage layer. It holds the stuff. This fundamental separation of compute from storage, that's the key. That's what makes everything else possible.
So why is that separation so important? Well, think about it. If one of your nodes fails, do you lose data? Nope. It's all safe and sound on Colossus. And recovery is lightning fast. A new node just has to pick up the pointers from the old one. When you need to scale up and add more nodes, you're not spending hours copying terabytes of data around. You're just quickly redistributing these tiny little pointers. It's fast, it's resilient, and it is unbelievably efficient.
All right, so we've seen how it works. Now let's talk about where you'd actually use it. What are the ideal scenarios where this killer combo of high throughput and massive scale really shines?
Financial data is a perfect fit. I mean, think about storing every single stock trade that happens or every credit card transaction globally. You need to write a ton of data super fast and then be able to read it back with really, really low latency. Bigtable was practically tailor-made for this kind of workload. Another classic example? The Internet of Things, or IoT. Picture millions of smart home devices, or industrial sensors, or energy meters, all reporting back data every few seconds. Bigtable can just effortlessly ingest these enormous streams of time series data without even breaking a sweat.
And this same power applies to marketing and analytics. If you want to store and analyze every single click, every purchase, every user interaction to power a recommendation engine or a machine learning model, you need a place to put that enormous data set. Bigtable is the perfect storage engine for that.
But, as powerful as Bigtable is, it's not the right tool for every single job. And it's really crucial to know where it fits into the ecosystem. So let's quickly compare it to a couple of other Google Cloud databases to see when you'd reach for one over the other.
This little table is a really great cheat sheet. But here's the bottom line. You use Bigtable when you have massive scale reads and writes. Think high throughput operations. If you need to run complex, interactive queries for analytics, that's a job for BigQuery. And if you're dealing with nicely structured document-style data, like user profiles, then Firestore is going to be your best friend. It's all about using the right tool for the job.
So we're going to end right back where we started. Your data, it's not going to stop growing. It's not going to wait around for your infrastructure to catch up. So the real question you have to ask yourself is this: how are you going to scale? How will you build your systems to handle not just today's data, but tomorrow's explosion of data? It's something every single one of us in this field needs to be thinking about right now.